Okay, so it's there. I like the infinite regress when it does that. Sort of a. All right, so it's capturing the screen. This will go. I'm going to bring up Canvas just to show you a couple of things. Again, if you go to the syllabus, the blog will have the diagrams I'm going to do today. I'm going to put there. And I just wanted to show you those diagrams from this morning. So there will always be like morning and afternoon ones for this. And they may not be the same. A lot of it just depends on what direction the discussions go. But you're welcome to look at both. And then the same thing, there are YouTube videos. So I just started that one. And I put them in like a playlist. I didn't know how else to organize them. So there's a playlist for every class. And this again is from the morning. This one for this afternoon, I attacked that afternoon on that. But you're welcome to look at both. One may be better than another. This one, I think, has some pretty big gaps in it. Again, they're just recording in class, so if you're doing so, I can't find a way to pause them. Does anybody know how to pause when you're recording? I can't find it. I know how to stop them, but then there doesn't seem to be a way to restart them. So they're Google Hangouts. So essentially, if you really wanted to, you could tie into the Google Hangout during class and follow it on your screen if you want. I don't know that that's a big advantage, but it is possible. So they'll be posted there, and the newest ones are always on the top. The other thing is you can go back, and there are things from other quarters, and you're welcome to. I've been doing pretty much the same thing for a couple years now. I did change. I made a significant change about a year ago, maybe a little more than a year ago, but you can go back quite a ways with videos if you want to, and they should be similar. Questions on that? I just wanted to show you those resources were there. Do you guys want me to work in Visio or in the other, the
Lucidchart?
Lucidchart?
Sure.
Sure, which?
Yes.
Well,
Lucid it is.
Lucid is nicer, but if you don't have access, Visio might be better right now. I don't know.
Lucid is free though, isn't it?
To Lucidchart?
Yeah, because we all have like a .edu.
Right, but it
email,
takes.
so-
They don't give it to you instantly, or
Oh,
did
yeah.
they give it to you instantly?
Yeah, I just logged in. I just signed up.
And they didn't have to email you back.
I don't know, put a password in for some reason. I don't know.
Well, there is a free account that goes away after a fairly short period of time.
Oh, maybe that's what this is. Yeah,
When I
yeah.
did it, although it may be under a different circumstance, it took a couple of days to get an email back.
It asked me if I wanted to upgrade to the EDU Premium, but I'm assuming maybe that's what that is, or
Maybe. I mean, I could do Lucidchart or I could do Visio.
Visio's on the computer.
The Visio is already on the computer. That's why I was thinking. I really prefer Lucidchart, but if you don't have the account, it could be a bit of a translation issue between the two softwares.
We're smart. We can figure it out.
All right, then I'll do Lucidchart. The other class did Visio, so it'd be good to have both on the blog anyway.
Look at both videos.
All right. So I'm going to go to Lucidchart. The other thing with Lucidchart, I think I have it in here, so I have to remember my password.
That might be the bigger.
Yeah. I'm a bit old-fashioned with some things. I keep a
Yeah, I think that's what we did.
notebook here.
I think we're doing
All right, so let's go to Lucidchart.
Yeah.
So I'm going to log in. I'm not sure how far you will get with the basic count. I was amazed at how limited the free account is. Yeah. Yay, so I'm in there. Now, if you go to Visio, what you want is basically a crow's foot diagram database. And here what I'm going to do is I'm going to get an ERD. So we'll do I think I'll hit the blank. Now, if you don't have, do I have the ERD shapes here? I just did blank. Flowchart, standard. Maybe should have done an ERD.
Oh wait, so you want to go to Blake now?
Well, I'm not sure. I might want to go to a database chart actually after I did this. You can add shapes. So I could, if I go to a blank, I can add the entity relationship tools.
I have a question.
Yeah.
So I just signed on to Lucid, it says scroll down, and then it wants to tell us, like, are we doing development ops? Design?
Do they have students in there?
Application?
Yeah. That's what I do, particularly since you're doing the free one.
Okay.
So I think you can come up with a entity relationship chart right away, but I can add the tools by just clicking on here. And the way I got this was, let's cancel and go back. The way I got this was to go to shapes, and then you can add whatever shapes you want. So I'm going to do entity relationship. Now, if I scroll down, it's been added to my shapes, right? And if I want those other shapes, I can, they have the little down arrow. If I click that little arrow, it'll go away. I mean, it'll collapse. So I can ignore them and just use the entity ones down below. You might want, like this is for a text box and things. Those are kind of useful, so I might leave them there. Questions on this? As I said, this is just for learning a little bit about the software. I think I get my brain going. You guys got to help me here. I keep pausing, blanking out briefly. I went to Idaho over the weekend to a wedding, and it's a long drive back. I didn't get back till fairly late, so if I'm incoherent, that's the reason. But question me if you don't understand something I'm saying. Ask, right? Because we want to make it clear. First thing I want to do is just show you an entity, and we did this a little bit last time. Is this big enough, by the way, or do you need it bigger, particularly in the back one? A little bit bigger. That looks okay once I get it in field here. Now I did notice there's a couple of different options here. There's one that just has the field names in the top. This one has the keys on the side. I think that's the one I would use. I wouldn't use the one with the 3 things there because that's basically if you need to add the data types. That can be really useful, and I have some. I might show you. One of the neat things that you can do with Lucid is you can go into something like Postgres or MySQL, and they'll give you a query to run. And then if you take the results of the query and save them and put them in here, it'll create the diagram. But that's after the fact. You usually want to do this before the fact. So does anybody remember what an entity is?
Like the table itself?
It's kind of a precursor to the table. It's the table when you're in design view. So the entities that you make in the diagram will probably become tables, but they aren't necessarily tables. You're working with the logical design. When you're working with tables, you're actually on the physical design, which means you're inside of a particular database. The tables that you're creating will be written to a disk, right? And each of these fields will have to have a particular data type. So the table is the real thing. This is in the logical or the design level. So if we did an entity, I'm thinking we might build a little bakery thing. because Vincent's is what you guys are going to do on for your assignment. So if we did a bakery, what would be one of the entities? Entities are things that the database is concerned with, right? If you think about what a database is concerned with, what kinds of things? Anything, whatever you come up with.
Inventory?
So you might have like an inventory. That's inventory, but inventory. Let's think of maybe one other. Well, let's just do this. Let's do, I'm going to do a PK here. And I'm just going to say inventory. And you can say ID or key. Well, last time I did key, so this time I'll do ID.
How are you writing in there?
I just clicked in there. Should be able to click in there.
Gotta double click.
Yeah, maybe double click.
Oh, thank
There
you.
go.
Yeah.
So a couple of things about primary keys, and we'll talk a lot more about them, especially when we get to actually building the tables. Anybody remember what are some of the things that a primary key has to have?
Has to be unique.
It has to be unique. That's really the main thing. It has to be unique within this table, right? Within this table, it can never repeat. The easiest way to do that is just to assign a number, right? 1, 2, 3, 4, 5, 6, 7, 8. There are some drawbacks to that, but that actually is the industry practice these days, is just to number them.
Question.
Yeah.
So what if the user decides to delete one of them later? Then there will be a blank.
It will leave a blank. It doesn't matter.
Okay.
I mean, one of the things you'll find when you do like enter data, if you delete a record, say you have 1, 2, 3, 4 for the album titles or whatever as a primary key, if you delete 3, 3 is gone forever. And they do that on purpose. They do it because they don't want any ghost relationships with that primary key hanging around, right? It is absolutely irrelevant whether your numbers are in a neat pattern or not, as long as each number is unique. In fact, you don't have to use numbers like 1, 2, 3, 4, 5, 6. You can use UIDs, universal IDs. Those are a bit of a pain. You know, they look like the product keys when you install software.
Mm-hmm.
They're just a whole bunch of characters, usually in kind of a hex notation. You could use Word. I mean, some companies use your email for a primary key, as long as it's unique. Emails are not great primary keys, but they will work as long as they're unique. It doesn't have to be a number. It can be anything that's unique. But the trouble with non-numeric ones is it's really hard to guarantee that they're going to always be unique. Like 2 people might share the same email.
Mm-hmm.
And if they do, that's a problem. You could just say, I don't care, we'll just do one of you. But anyway, that's that. Now, down here, what do we have? Does anybody remember what we call these? These are not keys right now. I know it's been a week. So these are called attributes. Even the primary key is an attribute. What are some of the things that describe an inventory item in a bakery?
Wheat, flour.
So, well, think of these as column headings too. Like flour might be an inventory item, but it wouldn't. On this, we're only dealing with the headings, not with the content under it.
Is it products?
So you might do. I was thinking something the high level like product name. Does that make sense? We might want to. We'll talk about later. I cannot type. Cap lock off. And naming conventions are kind of, at this point, what you want to make them. It'd be good to have a naming convention. If you work for a company, they'll give you a naming convention usually. What other things? Like product names, so like cake and flour and stuff, those would all be. One of the things about a bakery inventory that's a little bit weird is you have a kind of a mixture of things. So you have the dry goods and the the milk and the sugar and the all of that, but then you have the stuff that's actually being the product, which would be like donuts and cakes and I don't know if one should deal with those separately or not. We can talk about that later. Right now, I just sort of want to think about.
Maybe you could say ingredients.
Possibly. I'm not sure we want to, and then, so you might do that particularly if you're thinking of you want to price out the ingredients. I'm going to asterisk that so I remember to come back to it. Since you're not allowed to have arrays and things. So tab, it doesn't go down.
Value?
You might want to know the value and sense of how much it costs, which is, I think, where the ingredients are sort of going to. I want to insert a row below. And I right-click to get that. So I'm going to say cost. I'm not following any naming convention right now. I'm just trying to brainstorm things in here. What else might be in here?
Production date.
So yeah, the date. If you're thinking of the cakes and stuff, yeah, production date. So I said we might want to break this up a little later, but anything else?
Expiration date.
Yeah, so probably an expiration date too if you're doing that. Anything else you can think of? The gist of this is basically I just wanted you to, so an entity has a name, right? So when you think about, what entities are about, and we'll talk about this a little bit more in a second, but the elements that are important to whatever the database is, to the business. If you're doing bakery, inventory is one of the things. What are well, let's go to there in a moment. Then these are attributes, and attributes are things that describe the entity. Does that make sense? They're all bits, all attributes, descriptions of the entity. What are some of the other things that would be in a bakery? We're just gonna drag them on and add the names right now. I mean, I might have you spend a minute coming up with some fields. What else would you want in it? You have your inventory. What do you do with it? Yeah.
I mean, I was gonna say employees.
You might need to know at least something about the employees, right? So kind of like with Vince, we probably aren't going to do this as our whole human resources database. Small businesses like a small bakery probably outsource that anyway. But you need to know which employee is involved with which sales probably. What other thing might be in here? Are you guys as sleepy as I am?
Customers.
Yeah, you might want to know your customers. And again, with Vincent, you probably don't necessarily need to have everybody register. But if they order from you, you would want their information. If you have a rewards system, buy 5 donuts and you get 1 free. You could. It would be useful to have customer information for that. What other kinds of things? Right now, I'm just trying to get what entities might be in here. What?
Sales.
Sales, sure. So let's do sale. And anything else? You might want to know where you purchase your items. You might have something like purchase orders or something. You know, where you're purchasing not your donuts necessarily, but your flour, your sugar, your milk. Yeah. Anything else that you can think of? Guys haven't thought about bakeries much.
Well, so we have the cost of ingredients. What about like the cost of rent and,
You know, I'm not sure I would do that here. It is possible. So there's all the overhead expenses.
Yeah.
But I'm not sure if I would track them in the database because they don't change much.
Okay.
You could though, if you wanted to come up with some kind of comprehensive report on in the end of what everything costs. So I don't know. We could add expenses if you want.
No.
I'm just thinking. So
How many pills would you normally have or something?
so they can have a lot. Although I will tell you, one of the things that we're going to do is we're going to try to work through this and refine it as we go. So we can put a lot of things in here, and then we might find that we need to break things out a little bit and rearrange them. One of the reasons to do a design first is for that reason. A lot of times you need to look at a design, evaluate it, redo some things. It's a whole lot easier to do it with a diagram than it is to do it with the database. So it's easier to design. It's really an excellent idea to always design the database before you try to go in and build it. Because and particularly if you put it into production, then it's really a pain to change.
For some reason, it's harder to conceptualize a bakery than it is a record store for me.
That could be. The reason I chose a bakery is my daughter used to have a bakery. She has a restaurant now, which is... The bakery actually didn't do that well. The restaurant's doing great.
Is it here?
No, it's in Eatonville.
Oh, okay.
So that's way down by Mount Rainier. The governor ate there the other day. That was one of their highlights.
Put them on the wall.
So let's just go with these for now. I'm going to give you, this will be a little bit of a dead spot in the video, but I'm going to give you a few minutes and you can talk to the people around you. If you want, I'll group you, but you don't have to. Just take like 10 minutes and try to populate some of these out. And this is just brainstorming. As I said, in the real life, the way that this would have happened is that we would have reviewed all their documents. We would have reviewed their inventory invoices. We would have reviewed their sales, receipts and things. And we would have a whole list of fields pre-prepared. It's actually harder to do it this way where you're brainstorming off the top, particularly if you don't know the business. And, if you haven't tried a bakery. I thought a bakery wouldn't be too terrible. And it's a little bit of a retail thing, so it kind of relates to the Vincent's, like the sale and the purchase parts. So there will be some similarities.
So for employee, you put like their number, their address.
Right. So, yeah.
Yeah.
So I'm not sure I'd bother with. Maybe you'd have their address in there. That's something you might have their address in there. I'm not thinking that this is. So everything should have like a primary key.
Do these entities have their foreign keys be the inventory ID, or?
Well, so let's not worry too much about the relationships right now. That's where we're going next. Right now, what I want is just sort of to fill in the attributes. And there's no way you can get the one, you're not turning in this part. Two, when we actually do the assignment, we'll do them in groups so you can brainstorm them. Secondly, every group I'll meet with them and we'll go over it. If you look at the assignment, there's a first draft and a second draft of the diagrams. They're called ERDs, entity relation diagrams. So there's no way you should be able to get it wrong, because after the first diagram, I will correct anything I find wrong with you. And so just come up with a few fields, and then we'll, as I said, we'll modify these as we go on. I'll give you about 5-10 minutes. Yeah.
In terms of the visual design of it, is it usually like a tree or something like this, where it's like kind of just the signs?
however you can make it readable.
Okay.
Now there is this is meaningless though here. Once the relationships are in, there is an arrange, auto layout hierarchy. And what the hierarchy will do is it'll kind of lay them out by how they're related. It'll actually make it fairly readable.
Gotcha.
Because these are really become a mess fairly quickly. And one of the things I don't like about Visio is that it is really hard to make a readable diagram.
Yeah, 'cause it just looks like a page. It's
Yeah.
not a lot of space.
But there's no hierarchical existence here until we have the relationships. So I'll give you a little while. I don't want to give you too long just because I think you'll get bored. And then we'll come together and populate this out.
It's hard to get started.
Yeah, I know. As I said, you can't do it wrong. So we'll talk about them as we do them, and we'll develop it. And then the next thing we'll do will be relationships between them. The other thing is I don't expect all this stuff to sink in today. We'll have a few practices at it, so it'll. And you're quite willing, last time, we're welcome to work in groups, 2, 3, 4, whatever.
Yeah, I guess.
Guys are so quiet though.
Create a chart of that stuff.
So we have about 12 people out of 17 or 18.
Oh, yeah.
Yeah.
That's probably important. Address or
I'll be right back.
hours? Hours. What did you do for the full-time part? You just- Oh, gotcha. Yeah, that's not bad. Because if they're both, they're full-time, if not. Name your hours. Should we put their address or address and phone number?
All right, let's see.
No. So phone number probably, because that's probably how we identify people. They come in, ask their phone number. Oh, we get their name, of course. I don't think we want to store their personal information. Maybe number of sales? Oh, yeah. I mean, I think per customer though.
Give it a couple more minutes. And then
Cumulative sales now? So, we're bonus?
So he can't find right here, right?
Yeah.
So Tuesdays and mostly Tuesdays. Yeah, from like 1 to 4.
Ready to say.
Well,
Okay.
yeah, I mean, they're gonna determine whether they pay for it.
That'll be fine.
Email address? Email address might be useful.
Okay. All right. I don't know why you can't log in now. You should be able to. Okay. You need a minute more, or you got it?
We're good.
You're good? All right, what do we have? Let's just go through them, even if you're not done. It was to give you some time to think and me not talk. What do you have for employee? And if you have any new entities or anything, we can add them too.
Start date.
Possibly, as I said, this isn't so much. I guess you could do start date. That actually makes sense.
Probably want their name.
Yes, you do probably want their name. Again, I'm not following any naming convention here. I'm just sort of. Anything else?
Wage.
I'm not sure I would worry about that, but I'll add it for now. I wouldn't do their payroll here.
Hours,
What?
hours.
Possibly. You could track their hours, although we'll talk about that. Let me add a new row here.
Their phone number, right?
Probably want their phone number, yeah. So let's add. Now, a lot of this stuff, if I were, and I know my daughter does it, etc. For a real restaurant, they tend to outsource the payroll. It's just too much work. But anything else for employee? How about?
Would we keep their address or no?
You might, if you're using this. I mean, it's not for their like human resources. You're not keeping their tax information and all that. But if you need somebody to come in on short notice, having a phone number and having an address to tell somebody where to go get them might be useful. So we can add address. And address, well, we'll talk about it. I mean, you can break this up a bit. Again, ignore my totally inconsistent typing here. So, anything else for employee? We'll talk about some of these as we go on. All right, how about customer? So I'll give it a customer ID of some sort. What else would you want for a customer?
Total sale.
No, I wouldn't do the total sale. This is just for keeping track of customers.
Oh. Name.
Right. Yeah, so the name and phone number, or name and email.
Email address.
Yeah. One of the things about totals, and this isn't necessarily so obvious, is that generally you don't keep track of them because you can calculate them at any time. So you generally don't store them. Do we need anything besides email and name for the customer? The only time you would need an address, and I think maybe you'd want to do this. Let's add an address, so just in case you do deliveries. Does that make sense? If you don't do deliveries ever, you may not need their address. And you may not need the address for every customer, right? Just for the ones that do that. Is there anything else for a customer?
Maybe a birthday to track the discount.
You could. I know a lot of places do that. I'll put it in there. It didn't go. I kind of wish there was a shortcut key for doing a row below.
That's impressive.
Well, there's a field.
Where?
At the top right there, where you said you got 5 fields. There's 5 fields right next to standard.
Oh,
You just click it. It's literally right there.
oh, fields over there. And that adds a field?
Yeah.
Oh, I didn't see that. See, I learned something every day. So this was her birthday. They often use, I mean, I know they use birth date a lot for validation. I don't know how much we need to validate a bakery customer, but maybe.
Just bring them in for.
I started.
Oh, right, so they can come, they can have a reward on their birthday. Yeah, that actually is a good idea.
Oh, yeah.
So, those look pretty good. Let's do sale real quickly. Again, these are not necessarily our final versions of these things. We'll talk about them in a bit. But what about sale? So we have sale ID, right? Which or it could be sale number. That would be a primary key. What else do you need to know about the sale? The date. I'm just putting the field as date there. We could talk later about that, but date is not a good name for a field because it's a reserved word in too many languages.
Sale date.
Yeah, sale date would be better. What else would you want to know?
Amount.
Okay. Yeah, we're going to deal with this in a little bit more later. Let me see if I can do this now. Hey. As I said, we're going to deal with this in a little bit. Anything else?
Would one sale contain like multiple items though?
Yeah, see, that's the issue we're going to have here. So you remember I said that they can't contain arrays, which are lists of things? And another thing that you can't do is you don't really want to do something like product 1, product 2. Let's say you went out to 10, whatever. What would be the problems with that? What if you only sell one product? Because one of the things about database tables is that they're fairly rigid structures. They don't shrink and expand. I mean, the data, you can do it, but the rows, the number of columns, you don't shrink it and expand it.
So how about this? How about, say, if we have multiple entries under a sale with the same sale ID but with different values for product?
You can do that, but not in the same table. That actually is the answer. But you have to create a separate entity.
Or
Sale detail. So I'm going to do a PK here. We'll have sale detail ID. And then we're going to put in like sale ID. And then you would put in the, the product ID or whatever your thing is. So your products. And you'd have a separate row for every item in the list, but they're all tied with the sale ID to that one sale.
I do have to.
Yeah, you do have to. You can't do it in the same table. One way to look at it, when you think of a receipt, I'm going to draw a real simple receipt. Up at the top, there's usually like, I don't know, maybe the register number, might have the store information, probably the employee number, customer rewards number, name, date for sure. All right, so all that stuff is at the top of the receipt. And then down here, you have your items with the quantity and the price, right? So it does that for each of these, and then it has its subtotals and totals down here. So that's a typical receipt. So all of this stuff would go in sale. And all of this stuff would go in sale details. And within the sale detail, each one of these is tied to a sale ID, right? They're all tied to the same sale ID. But you have to break it out because there's no way in a single table to expand and contract, right? And arrays are forbidden for lots of reasons. One of the reasons why the product 1, product 2, product 3, I didn't finish with that, wouldn't work is, one, if you only order one product, you have, say, 9 empty fields, right? So it's fairly wasteful of space and other things because it prints a space for all of those no matter what. And if you were to search for something, you would have to search 10 different fields to find a particular product on a sale. And if you had 11 items, you have no place to put it, right? So that doesn't work. It also doesn't work just to list the items and then separate them by commas, because then you again can't find that item if you search for it without doing programming where you do a string, you'd have to do a substring and look for it. So in general, we don't. One of the rules that we're going to look at a little bit later is no arrays, right? No arrays. And no listings.
So is the sale detail entity, is that going to contain all of the products that we sell?
Yes.
Oh, okay.
It will contain every sale and every item in the sale, right? And they'll be tied to the actual sale and the date and then all of that by everything. Now the amount in the product then would go away from over here. Oh, I just undid the whole thing.
Don't do that.
Control Z.
That can go away. And I want to delete row and delete row. There probably is a way over here to delete rows too,
Yeah,
right?
at the field too, you can just go back.
Oh, okay. So that's one of the things I wanted to show you. This is a real common structure, right? And we're going to find other things like that. When you think about hours, depends on what you're talking about with hours, actually. If you're thinking hours in the sense of what are the shifts that they work, is that what you were thinking?
Yes.
Oh, okay, then that could fit in there just fine, right? Because you could just say, but if you're thinking about how many hours they actually work, that might have to be done in a different table where you did they actually show up for their shift for them? So, you keep track of that in a different place. Okay, other things. What did we have for purchase? And then now under here, there could be more here, right? We'll work these out a little bit more thoroughly later. What would purchase be? Purchase is where they're buying, right? Where the bakery is buying from some supplier.
Oh, then I guess a vendor.
So you might have the vendor.
Well, probably purchase ID.
Yeah, so purchase ID. And that'd be a PK. But vendor. What else? Anything. Yeah, so the product. And one of we'll talk about product, and I'm using product here.
Warranty.
Oh, warranty. I didn't hear that.
No, I said that too. I was just thinking.
Would there be, I guess it depends on the product.
Okay.
Which is actually, again, that we have this issue with the bakery that there's different kinds of products involved.
What do they take it for spoilage and?
Yeah, I mean, actually, that's what I say. When we were talking about inventory, there's the stuff. Bakeries have a lot of spoil. My experience is that they just sort of write. They don't even pay attention to it. I mean, they just throw stuff out at the end of the day. They pay attention to what they buy and what they sell, but they tend not to pay a lot of attention to the spoilage. Is anybody working groceries or anything? How do they handle that? Do they do a set amount for spoilage, or because they throw tons out also? Do you have something?
So the sale detail is gonna link between sale and inventory, right?
Yeah. So the product ID, we have an inventory, so it'd probably be the inventory ID.
Wouldn't it make more sense to like, instead of doing, just rename it like transaction detail, and then you could link the like purchase ID, and you could just have everything under like transaction.
Possibly. So I've actually debated that with myself at different times. One, you don't want to name a transaction,
Oh.
just because it's a reserved word in database. but the concept, yeah. So you would combine purchase and because they have the same kind of structure.
Yeah, you could just have a.
But there has to be something to distinguish them also.
There'd just be like a little flag inside the entry.
Possibly, you could do like transaction type. Does that make sense? I've debated that. You want to know the purchases separate. It depends on if the fields are truly identical. Right? Does that make sense? If all the fields are identical, then it makes sense to combine them and just put a flag in there. Say a flag being basically just a field that says transaction sale, transaction purchase, that kind of thing. But if the fields are substantially different, for instance, the vendor is a little bit different, then it would make sense to separate it out as its own entity. There's a lot of puzzle to this. There's a lot of trying to figure out all the pieces. And in a real situation, it gets more and more complicated as you go on. All right. I want to do one other real quick thing. I think we have time. And then we'll come back to this and start refining it more. I'm going to make one more diagram. I suppose I could do it at the bottom of this diagram since it's almost infinite in size. I want to talk about how things relate to each other, and then we'll come back and do those relations a little bit. Probably a new diagram makes sense, though. So I'm going to do File New. And let's do an entity. Let's just do a blank ERD. That way I don't have to actually import the tools because they'll already be there. I'll close these. Okay. So I want to talk about, I'm going to get a text box first. Did I make a text box? There it goes. All right, so does anybody know, it's okay if you don't, I'm just curious, does anybody know what kinds of relationships can happen between database tables? Entities? There's 3 of them, if that helps.
Engaged, married, divorced.
Nah, that's actually a good idea though. So it's more of a like one-to-one.
One to many.
One to many.
Many to many.
Yep. Many could be more fun. Interestingly, many to many. Well, we'll talk about them. So one-to-one is there are only these 3. Is that big enough to see from the back? You're okay? Okay. So one-to-one is very rare. It is perfectly legal, but it's extremely rare. You may never encounter it. I'm going to show one of the one of the scenarios where this happens. I'm going to say employee public, employee private. Or you might do it as employee HR. I'll make this a PK. And we'll just do employee ID. And I'm going to just give a couple of things. Like this would have like their name. It might have like their position. It might have their office, etc. All right. So the idea here is that, so I'm going to do the same PK here. And I'm going to do employee ID also. And this one, though, I'm going to do like a social security number. Deductions. I'm, these will be broken out. Deductions are a complicated topic. And let's just add a, so it might have like their home address. Let's get rid of these keys. All right, so these have the same primary key. The only reason you would do this is sometimes for security, they'll break out a public-facing table from a private one. Right? For every one employee over here, there is exactly one employee over there. Right? It's just, this is just the same person's record. This is the private elements. This is the public elements. This is a buy that this isn't the best way to handle security, but it is something that people have done. So I'm going to, right here, I'm just going to drag across. And then I want to change this to that. Is that going to work? No, that just changed the styles. That's not what I wanted. I want to change that endpoint. Is this it? Yeah. That didn't change it, though. I want to change it to one-to-one.
Or shouldn't it be the other one?
What?
You can click on it, and then top right corner, there should be another one.
What, over here?
No,
Top right corner.
just, yeah, that one. That one.
Yeah, but it didn't seem to do what I wanted. There it did. I think it mustn't have been selected at the moment I did it or something. So this is a one-to-one relationship with the crow's feet. There's no crow's foot. There's just one-to-one across. This relationship is legal. Databases support it, but it is extremely rare. Right, so you wouldn't find it very often.
Yeah, can you explain what the, like, one or two,
Yeah, so
one-
those, I'm not going to worry about those, but this means there must be one over here, and there will be one and no more than one over here. So what these relate to is cardinality, which is how many are required. You can safely ignore them for the most part because databases don't enforce cardinality. The design process, they pay attention to it, but the database itself will ignore it. So,
If you built this to be secure, would it differ substantially from how it's structured here?
well, so I mean, you could do this. Basically, what it is you would make this so that only certain people had access to it. The thing is, you can create this all in one table, and you could create a view that only exposes this to the public, and the view is what is you're actually calling on the form. And you could give permissions to the view and deny permissions to the table. Does that make sense? I mean, we're not going to spend a lot of time on security, but it is possible to secure it, particularly if you don't give them you should never actually give users direct access to tables. You should always create an intermediate view or form, procedure for them, so that there's something between them and the actual tables. But that's a different class where you design that. The thing with database people is that they don't trust developers at all. So you have to create a security layer between you and the developer. Now, in MySQL PHP, that's not so common because often the database developer and the programmer are the same person. Which the bad part about that is that they trust themselves and they make mistakes. So it can be a problem. But this is one-to-one. So I'm just going to, on the side of it, just do one-to-one. And again, it's really rare. So I am going to do, and this is just another pair. It could actually relate directly to the other one. So I'm going to do like department and then employee. And we'll make a PK with the department key. Let's just do ID. I've been doing IDs, so let's do an ID. You know, things like department name, etc. If your thing goes too long, you can stretch. Oh, I didn't want to do that. I just want to stretch this out. I don't want to make a.
It's not good to use the, like, just 50 part.
You could, but I guess I'll just leave it. So this is employee. I'll do employee ID. And we could use the one above, but I want to show the relationship separate. I'm going to do a foreign key, department key, department ID, and I'll just note that went the wrong way. There we go. I know there's a way. There it is. Now that just moved it.
Oh, so maybe
No,
a
the
little,
blue one.
little square in the corner?
There we go. I knew I'd done it before. All right. So, assuming that every employee only belongs in one department, you could do a one-to-many here. And that's what it defaults to when you draw, right, the thing. One department can have many employees. And the reason it defaults to that is that 99.9% of your relationships in a database will be that, one-to-many. One department contains many employees. Is that clear? I mean, that's the easiest relationship. That's the one that most things will have.
That's one to many.
Yeah, that's one-to-many.
Why is the 1-to-1 2 ones?
Again, I wouldn't worry too much about these. This means that one is required and one is required. This means for everyone here, there can be many over here. It's not necessarily required. And there are other variations of this where you have zeros in here, which means one or zero, you know, and zero or many. But again, the database doesn't enforce that, so it's really the only thing I'm going to care about is which side the three-prong thing is and which side the one side is. I don't know that any of the databases that we're doing will actually have a one-to-one. So it'll all be one-to-minis. But we do have one other. I'm going to just label this. We do have one other relationship. And let's do, last time I did books author. Let's this time do student. And we'll do class. And we'll make a PK. Student ID, PK class number class key, class number. I'm not going to fill in the other fields right now, but what, so let's just do, so I'm just doing the ID. A lot of times for when you're just trying to figure out relationships, you don't necessarily need all of the other stuff. What is the relationship between a student and a class? What? I heard something, but yeah. So, well, one student can take many classes, but one class contains many students, right? So this is a many to many. I don't know. Let's see if I can change this to a many to many. So you have, see how you have zeros and lines. So the 0 means 0 or many. This means 1 or many. This is just many. I'm just going to go with that. This is many to many. One student can take many classes. One class can contain many students, right? This is perfectly legal in a design aspect, but the database itself, and this is true whether it's Oracle or SQL Server or Postgres or MySQL, they can't resolve this. It's like an endless loop. Basically, what will happen if you create something that has this kind of relationship is that you can't enter a student until you enter the class, but you can't enter the class until you've entered the student. Right? You're just, it's frozen. It's in an infinite loop. So relational databases cannot handle many-to-many relationships. So what you have to do, anybody have a guess?
Put the student in first. Create them both separately and then link them.
So you create a link. The link is a good keyword there. So I'm going to bring in another. We'll do another student, and we'll do another. So we'll do a student. We'll do class. We'll do PK student ID and PK class. Number. Did I do class number before? Okay. So what you have to do is you have to create a linking table. We could call it student class. You could also call it roster or something. And there is one way, you don't have to do this, but I'm going to do student ID as a PK and class number. All right. And what happens is that there's a one-to-many relationship between student and class, and there's a one-to-many between class and student class. One student can take many classes. One class can have many students. This results into two one-to-many relationships. This is not necessary, but you can do this. I just wanted to mention. It's called a composite key. We'll talk more about keys again when we're making them, but composite keys are, no table can have more than one primary key, but that primary key can consist of more than one attribute. Does that make sense? What would happen is that the pair of these would have to be unique. So say you had a class 1 and you have 30 students. This could be 1, 1, 2, 1, 3, 1, 4, 1. But the pair would always be unique, right? Let's see. Dubious looks. Anyway, it's like the pair could be. I kind of like these with linking tables.
So you said you have to do this, or
no, you do not have to do this. You could just create a student class ID.
So you said the top version wouldn't work. Right?
This version will not work.
It's the chicken or the egg. And so.
So you do have to create a linking table.
Oh,
What you don't have to do is to do a composite key. You could just do a student class ID or something. The reason I like composite keys for linking tables is they prevent you from like assigning the same student to the same class twice. Does that make sense? Because the pair always has to be unique, so it kind of keeps you from accidentally adding somebody twice to the same class. But the linking table is required.
So is it called a composite key when you have multiple?
When you have
keys?
there's only one primary key, but it has multiple parts. Does that make sense?
I think so.
These are rare and you should avoid them. The only time I use them is in linking tables. If you use, like if, an example of a composite key, if you wanted to do a key based on the class number, so think about the way courses are done here. So this is 3196, right? So the class number. The trouble with that as a key is that they use it every quarter, right? And they don't necessarily use it for the same thing. So you would also need to do quarter, right? So you need to know which quarter it was. And you'd also need to know what year it was. So you need the item number, the quarter, and the year. In order to get a unique thing. So if you were using those to identify class, you could do it with a composite key that has three pieces. There's a bad thing about this. If I relate this to anything else, I have to repeat all of these because they're all part of the key. So you get a lot more repetition than you probably want.
and just number by year.
The
The year is part of the.
year is part of it, right? Because if you're looking for classes, so 3196 is offered 3 times a year, or 4 times. Usually, I don't know if there's any summer sections under that, but so the 3 quarters, but they're also the same year, and it's the only way to get a unique there. The other thing you could do is what I would do actually, is I would randomly assign like a section of the or something, just a random number to it, rather than try to break up 3 natural elements into a unique. That's the trouble with using what they call natural keys that are part of the logic, is that it's really hard to come up with something that's always unique. And you end up with a lot of times with combinations of things, and it gets to be a real. If you remember anything out of this, remember that when you have a many-to-many relationship, you need to create a linking. Does that make sense? And I don't expect you to remember all of this today, actually. This is, we're introducing it, we'll play with it for a few times. We're gonna do, a couple of designs and review them and things, and you'll get some practice. This stuff is complicated and takes a while to make. So if it's not making sense, don't panic, but also feel free to ask questions. Yeah.
How common is a many-to-many?
They're fairly common.
They are.
Yeah. So the trick, I'm not sure if I said this, but one of the tricks with these, always resolve it. But the other thing is you have to recognize, right? A lot of times they happen. Let's go back to our other diagram. I could have added just a page 2. That would have been better than doing a whole nother diagram. So let's see if I can get back to the view file. I want to get back to my documents that I had before. There is a way.
Is it not one of those tabs up there?
I'm sure it is. One of these?
Just like your browser tab, the blank diagram up there.
Okay, you're right. It did. You guys are better at navigating these than I am. I've been using them quite a bit too, but. So let's think, now some of these are going to have to be refined a little. And the thing that we're going to do next time in the morning, I mean at the beginning, and then we'll start our work on the assignment, is talk about normalization. But we can start a little bit of that now. But let's think about what relationships there are between things. Let's start with sale, because we kind of got that. We don't have necessarily all of our fields in there. What would the relationship between sale and sale detail be?
One to one.
Actually, it'd be one to many, right? Each sale can have many details. One to many. That's a fairly easy one. We just had to break it out because there are multiples there, right? So a sale can have a customer, right? I'm going to move customer down here a little bit. So what's the relation between sale and customer? We don't have a field in here.
Say one to many as well?
It is. So one customer can participate in many sales. It's interesting the product came back. I'm just going to click. Also, it doesn't matter particularly in these diagrams where these relationships hook. It's not like you're trying, it has to hook directly to customer ID or something. That makes sense. And we can always do, and probably should do, like a foreign key. So we have product. Now, one of the things that we didn't actually do much with is this inventory. Yeah, I'm sleepy too. We've got a kind of a mix of things in there. How would we want to do with inventory? Is there something difference between the product and inventory?
There can be many instances, so to speak, of the same product.
Yeah, I mean, I'm not entirely sure of this right now, actually, but my first instinct, let's see if I can move these over, would be to separate out a product table and product ID. And then you might do things like description, or at least name. Possibly ingredients. I'm not sure how I want to deal with ingredients there. What else do we got? One of the things that this product table would be, though, is it would be a very abstract. It's not about what products are in inventory right now. It's just a list of all the products that you deal with. Does that make sense? And then in inventory, I think I would reduce this to product name or product ID. And I think these would still relate in the inventory because these are separate from the dates, right? This is just a description of the different products that you do. You might, I don't know where the price should go there or in inventory. Anybody have a suggestion?
Is product on top of inventory in this case?
Yeah, so I'm thinking that product is a list of just the list of all your products. You want to enter them once, whereas they might end up in inventory more than once over time. We'll have something similar in Vince, so I'll give you a heads up. So you have your albums, but if you put them all in inventory, you might have the same album information listed dozens of times in inventory, right? Rather than do that, what I would do is I would create an album table that lists all the albums, independent of things like condition, independent of, so you list the album once, and then in here you just do the album ID, and then you add the specific things like the condition and the price paid and all of that. Does that make sense? So this is just sort of so you don't lose the information about the album if you delete it from inventory. And also so you don't have to repeat that information over and over again.
The album table was like a catalog then, basically.
Catalog, right, but I wouldn't bother doing like the entire internet of the albums,
Just
but only
everything.
just the ones that you've
Yeah.
actually had.
Why not artists?
Um,
Where would artists go within that?
So I would do artists as a separate table.
Further up the chain?
Yeah, and then you'd have a linking table between artists and album. Because there are a lot of compilation albums. I would not, for Vincent's, I would not try to differentiate like members of a band. Well, I mean, you have people that switch in and out of different bands and things. So I think I would just do the band name or the artist's name. But there are a lot of
So Beatles and Paul McCartney.
yeah. So Paul McCartney would be a separate entry than the Beatles, but you wouldn't try to cross-reference them. If that makes sense. You could do that, but databases like that exist on the internet already. You could look it up.
Okay, hold on 1 minute.
I think Neil Young's been in an awful lot of bands too over the years. So yeah, does that make sense? So I think I would separate out product and do a product there, and the relationship here would be the same, right? One to many. Now ingredients. What is the issue with that? And it's sort of the issue that we had with the sale. Anybody? So you can't do, I asked her because I wanted to come back. You can't do arrays. You don't want to do a lot of listing, right? So how do you handle a plural value like that?
Not about this, but actually I'm just kind of still trying to figure out the relationship there. So is this saying that we have many inventories?
No. One product can appear in inventory many times.
Okay.
And product, remember, is just a generic listing of like donut or cake.
Okay. I can get that.
And you'll have it in different inventory, and particularly if you're keeping track of a history of what you've had in inventory, then product ID could appear many times, you know, every time you add a new one to inventory or something. Depends on how you do inventory. And that's something you'd have to figure out. All right, so ingredients,
Another table.
yes. Anytime you have a plural value, you need another entity. And not every product would have ingredients, and that's fine. But the ones that do, so I'm going to do and I'm going to ingredient name, say. And you might have things like the measure or amount. But I would also hook in like the product ID. So I'll get it where you can see it here in a second. This would be a foreign key. So we've got product. I don't know where would be the best place to put this, but just do it like this. So for those products that have ingredients, you can list the ingredients, and each ingredient would have its own ID and things. Now, you might actually, that's probably not how you would do this either. Anybody know what the problem with this would be? I'm not expecting this, but I mean, just if you're thinking about this, this is where things get, each product could have multiple ingredients. Each ingredient could go to multiple products. So you probably actually want a linking table between product and ingredient.
I like it complex.
Yeah. Real databases often have hundreds of tables. And a lot of them are just doing this, resolving relationships. So I'm going to say product ingredient. So I'm going to have the ingredient to the product ID. You might also, this is where I would put the amount. And you might also have like a note. So I'm going to do these as FK.
Is there an easy way to denote like a linking table as that? Or would you maybe just like color code it or something?
There might be a way to color code it. You could probably in your naming convention. Oh, got rid of my FK there too. You could probably instead of doing product, you could do product ingredient or prod ingredient. I don't know how you want it. Linking. I mean, you could put linking in the name if you wanted. So here I'm going to get rid of these. And again, you might have other stuff about, actually I want to get rid of that. Wrong way. You'd have more things about ingredients, but whenever you have a plural, you almost always end up with a, like that, with a linking table. Is any of this making sense? Nope. What the questions? Let me kind of zoom down a little so you can see more of it, even though I know it's harder to read the details. Why is that such a mess? Yeah.
When you're putting like a relationship lines from one entity to the next, does it matter which piece that you're linking to which? Like, are you?
No, it's you're linking the entities. You're not actually. Typically, these don't try to point to the actual field that you're linking.
Oh, yes.
The FKs are for that. Although there are some environments we'll be in where there isn't any FK available. You just have to know them. Another thing that I do that makes it easier to tell what links to what is that I notice that the product ID is named the same thing in both. I name the foreign keys the same as the primary keys. You do not have to do that. But I do to keep it clear. In my mind, it's clear what relates to what if they have the same name. Does that make sense? You could also probably color code things if you wanted. As I said, this will take a little while. Now, like in the sale, we have the product ID, but it would probably be the inventory ID. And it would be a foreign key, and it would link to inventory. I'm going to do that link. I'm going to show you one of the things you can do too. So I just choose one of these things and try to come down to sale detail here. And then we'll move that out of the way. Customer, sale. Customer is linked to sale. Sale is linked to inventory. Is everything linked together? Employee should be linked to sale. So I would probably put the, so let's do it down here. So I would do the employee key here, or employee ID. And I might want to move the employee down, but I'll show you something that's neat about this in just a second. So we're getting a mess, right? This is a pretty big mess. This is neat. You can do a range, auto layout, hierarchy, and it will create a fairly coherent. Now purchase isn't tied to anything because we haven't dealt with it yet, but it will create a fairly coherent chart out of everything. So the arrange works pretty well. And that's actually what an entity relation diagram looks like. Basically the entities and the relationships. And you can build the database directly from this. We're not quite done refining it. I think we're going to spend probably next time mostly doing that. But you'll see, you know, when we're done refining this, you will have these are tables. You just go into your software and you design the tables, and in the software you also have to create these relationships, right? You have to show how those things relate. They are called constraints in the software because they do constrain how things behave. Talk about that a little bit more later too. But these lines represent actual physical things in the database, and these represent things in the database too. They represent the tables. And once you've got this laid out, then it's fairly easy to go. If you just dive into the software and try to do this off the top of your head, but we're kind of doing it off the top of our head, but if you just go into SQL Server and try to do this, chances are you'll make a mess. It's better to make a mess in your diagram and then fix it than it is to try to make a mess in your database and then fix it. Other questions? That's probably about enough for today. I don't expect this all to sink in right away. Right? This takes a while. This is complicated. This is, as I said, it's like putting together a puzzle, you know, and it can get even more complicated than this. But it is complicated. This is a fairly simple little thing. You'll find that Vince has some of those. I did this partially because Vince's will have certain elements in common.
So for that assignment, we're going to be working on that in the next session.
I think we're going to talk a little bit about normalization, and then yeah, we'll start beginning on that.
Gotcha.
I don't expect you to finish it on Wednesday, but we'll start it. So even though it's due Wednesday, don't worry about that. You know, it'll take us, I think, at least until early next week to get the first draft. So don't worry about it too much. If you want to look at normalization, you can, although I don't necessarily advise that. There is I think there's a Google slide or PowerPoint for normalization that you might look at. I'm just going to real quickly do like normalization, just to show you what. I probably should do database normalization. Let's just do data normalization. Wikipedia isn't bad for this. It's not great. But it talks about why you would do this. What normalization consists of is these normal forms, and each one of them is like a white paper that was written by a data scientist to try to explain how to avoid certain problems in your database. And we're only going to go through the third normal form. So there's the unnormalized, first normal form, second normal form, third normal form. If you get there, the chances are really good that your database will work. These others are just refinements, and they get more and more particular to where you get, when you get towards the end here, you end up with tables that are almost nothing but keys. And the trouble is that although you met the logical and mathematical requirements for a self-consistent database, you've usually made performance impossible. So you usually have to undo a lot of what you did in order to let it perform better. You're welcome to look into a lot of those things, but we're only going to look at the first 3 normal forms next time. When they were written in a quasi-mathematical and predicate logic and set theory. We're not going to look at those, but if you ever want to look at the original papers, they're basically math papers. So, but in Wikipedia's explanations aren't bad. There are some others that are quite better, but Wikipedia's aren't bad. So that's what we're going to look at next time. And this is just to refine it further. They're basically to make sure that your entities are self-consistent, that they're all about one topic, right? So if you're mixing things in, and you don't want to, every entity should be about one thing and one thing only. And then make sure that there's no dependencies on anything within the table. The data should all be independent of each other and relate to the topic.
What's an example of a dependency?
What?
What's an example of a dependency?
So this is getting ahead, but I'll show you real quickly. So a dependency, say you had a book entity, or even an album, right there. So you have something like the title for the album. You have the key again, the album, whatever the key is. You might have the label. And then say you did the label address and the label email. I don't know if you want all of those things. And then you might do like, I don't know, the year of the album, etc. When you have something like this, all right, a couple of things. This means you have a subgroup that's really related to the label, not related to the album. So that, and these things are interrelated. They're dependent on each other, but they're not dependent on the name of, what's going on in the album. Typically what you do with this is, with all of these things, you create a new table for the label, right? You shouldn't have fields that are related to each, like these are all describing the label, but not describing the album. That's a dependency. They're dependent on label, not. They all should be dependent on the.
So as there's no dependencies, just take it and make its own table and that's all.
Yes, yeah. Almost everything, the solution to almost everything, plurals, dependencies, is a new table. So that's why these things get, that's why you have databases with hundreds of tables. And just one last thing I'll say, and then I'll let it be for today. The drawback of relational databases is their complexity. And it's fairly easy to make a mess, right? Once you get the hang of it, you can make sure and if you go through these normalization processes and things, you can be pretty sure you can get to where you don't make a mess, I guess. That's the thing. But relational databases are complex, but they're modeled in a way that the computer can handle them really well. And that's partially because they have a mathematical underpinning, which we don't have to learn the math for.
Thank God.
If you're really interested, I might be able to point you to some of the math. I used to have some big textbooks with the math. I had a student that was interested. I lent them out, and I've never seen them again. So I'm sure they didn't mean to take them, actually. But I don't have them anymore. But I probably can find the math. They usually call it tuple calculus, and there's also some parts of algebra that apply, and then set theory. Luckily, we don't need to know that, though, to use it. So what I'm going to do, I'm going to stop the video. I'm going to take pictures of the diagrams that we did. I'll put the diagrams in the blog. One of the things that in the blog, did I have the blog up? I did at one point. If you click on the picture, it'll expand because they're not always real readable in the blog format because they're compressed to fit into the column. But if you click on them, it'll take over the screen. So, other questions? Guys, okay?
We made it.
Yeah, so next time we'll do a little bit of talk about normalization and we'll start on the assignment. And again, you can't go wrong because after you guys have worked on it, I'll come and review it.
There would be enough to wait for that.
What?
There would be enough to work on it.
For the assignment, yes. So actually there's two steps. If you look at the assignments, there's a first ERD. So you turn that in and then I'll review it. And basically I think there's a rubric there. I usually just give everybody all the points for the first one because it's just meant to be a rough draft. I'll review it and then I'll come meet with every group and go over it so that you know what corrections to make. So you can't do it wrong. Okay, so what was I going to do? I was going to stop my video.